Hi, my name is Rick, and this is a workflow demonstration on fast and iterative world building using gray boxing techniques for virtual production. These principles are applicable across all tools and pipelines. I'm using Unity. You can use any real-time render engine you like. We're going to do a lot of cool things today that are designed to get you quickly and efficiently out of the technical and into the creative process as soon as possible. I am going to demonstrate the benefits of creating your own virtual production toolkit, transferable from project to project, that will jumpstart your world building workflow, eliminating routine technical work that is common among all virtual production work. And we will do this in the service of building environments around real world production stage dimensions using stand-ins. And we are going to use virtual camera sensors to accurately frame what our real cameras will see on shoot day, so that as we build our worlds, we have a solid one-to-one idea of what it is our production cameras will see. This includes field of view and sensor sizes. Beautiful stuff. We're going to learn to more efficiently spawn objects where they belong in our virtual worlds rather than shifting and moving them around through a trial and error process, which eats up a lot of time, can be a bit draining, and is inefficient. So we're going to circumvent those problems, and I'm going to show you how that's done. We're going to then quickly use these techniques to gray box our virtual environment layout and enable iteration, so that we can change things without slowing down the workflow or bogging ourselves down with unexpected problems later on down the pipeline. We are then going to place camera origin markers to align virtual and production cameras while shooting. And we will discover the benefits of using virtual talent markers. And we will finally replace our gray box stand-in elements with production-ready assets. So let's get into the fun stuff. Let's get into Unity. I like to begin every project with scale references for the shooting stage where we will be working and build around that. Case in point, what we have here on screen is a visualization of my home studio desk, real world dimensions, which I simply measured out and then represented via a cube. And then on the floor, I have a small plane, which represents the amount of space that my chair takes up. When I'm seated at my desk, it represents the floor space that I might move around in as I'm performing from my desk. Seated at my desk, we have a stand-in mannequin. This is a scale reference to my height and dimensions. This gets me started. I also like to know exactly what my real-world production cameras will see on shoot date and build accordingly. So I use a previs camera, and I have one here that is set up for the position of facing the desk. Now, what's special about this previs camera, and why is it different from the Unity default main camera? Well, the differences are that I'm utilizing a custom sensor size, which matches my production camera, and focal length is also representative of my production camera, which means here in the game window, what we are looking at is a really close, a near one-to-one, if not exact one-to-one representation of what we will see in the final virtual production. This is a great place to begin. Let's continue and build off of this. What I like to do is always organize my scenes from the beginning, keeping things clean and organized. So I'm going to create an empty, and I'm going to name this regions. I'm going to make certain that the transform for this game object is set to 0, 0, 0. That's the absolute center of our world. Within regions, I'm going to create a second empty. I'm going to call this stage floor. And this is representative of our world origin. Additionally, I'm going to create another empty, which will be representative of our background elements. Within regions, I'm going to create an additional empty and name it background. I'm going to push this empty way off into the background where backgrounds belong. What is the purpose of these regions? Well, Unity loves to spawn objects wherever you are looking in your scene view. So if I'm looking over here and I create a cube, that cube spawns here. Now, if I want to place this at our world origin, I have to back around, move it about, maybe change my view. You see, it gets messy really quick and you have to do some navigating. I don't like anything about that. So what I enjoy doing is selecting a region, in this case, my background. Select my background, I create my object within it as a child, and it appears exactly where it should. Even if I'm looking way over here, background, 3D object, capsule. Where's that capsule at? It's exactly where it should be in the background. I'm going to speed up my machine by giving it a better resolution. This is a beautiful way of spawning objects where you want them to spawn. So I can do the same for the world stage origin. I can 3D object, create a cylinder, and you'll notice that the cylinder spawned really close to my main stage elements. This is how I like to work. Let's delete these elements and build more practically. Let's give ourselves a stage floor. We have a stage floor area, but let's give ourselves an actual physical ground to stand upon. Throw on a plane, beautiful. We'll just scale it up because later on, we'll make use of a larger floor when we use talent markers. Background, I'm going to bring this and position it right at the edge of the rear of our stage floor. Beautiful. Now, in our background, we probably would like to have a wall. So let's place one for ourselves. And I'm going to show you along the way a really neat trick for scaling it simply and efficiently. It allows you to simply grow a wall taller or shorter from a custom pivot point. So within background, I'm going to create an empty and call this cube pivot. And within cube pivot, I'm going to create a wall. So we'll build this out of a primitive cube. Let's zoom in, and this is how we give our cube a custom pivot. Currently, the pivot for the cube is at its center of mass. We can simply change the Y position of the cube itself to be half the height of our scale. So our cube is 1 meter on all dimensions. I'm going to raise it up on the Y-axis by half of this, which is 0.5, which also places the base of the cube onto the floor. Now, if we look at the cube pivot, it's still in its original position, which means if we scale the cube pivot and not the cube itself, we will scale the cube from its base rather than from the center of the cube's mass. I'm going to tap into R and I'm going to scale it outward and I'm going to scale it upwards. And you can see that the base of the cube remains on the floor. It's not growing below the floor as working with a normal cube would. In fact, let me show you that really fast. Cube without a cube pivot. Now, if I were to not use the cube pivot method and simply scale upwards, we can see that it scales in both directions. We don't need a wall to scale into the ground, so we just want it to scale upwards. That's the benefit of providing yourself with custom pivot parent objects. All right, so using the game view, I can grab my pivot and I can just simply scale so that my wall fills the frame of view. There we go. So now we have a wall, we have a floor, and we have a virtual camera representing our production camera, and we have a scale reference of both performer and desk that will be in the final production. This brings us to a wonderful place, which is gray boxing to create depth and separate virtual production from simple digital backgrounds. What we have now is just a digital background. There's really no difference between what we have here and a Zoom background. Sure, we may be in 3D space, but this is just flat and boring. So what do we do? How do we fix this? Well, let me grab my sun and rotate it so that it's raking across our world. Now, we want depth. A great way to have depth is I'm going to add some widgets to the wall. I'm going to select my background region and create another cube. So I'm going to just bring this forward, half out of the wall. All right, so there's that, and we will scale it up. Let's just, let's position. Let's just move this right over here. We will duplicate, and we're just adding a little bit of texture to an otherwise extremely flat, featureless wall. So now we have a little bit of something representing shape, but we'd like to throw something on the ground as well, correct? I'm going to grab these and parent them into an empty parent, and I will name this wall. This is our wall and our features of our wall. Now, also in the background, let's create a couple of stand-in floor elements using cylinders. I'll bring this out. I'm guiding my placement of these elements using the game view through the camera. I'm going to duplicate and bring this out. I'm going to shrink this one down a bit. That'll be just fine. And let's do one more over on the other side. About right there. All right. The secret sauce to convincing virtual productions is foreground. We want to see elements in the foreground. Yes, of course, our performance is in the foreground, but we have to remember that when we replace the stand-in and the stand-in elements, such as the desk, with our live camera production feed, it's functionally no different than a camera performer in front of a green screen. But what if some of the virtual elements are in front of the performer? Well, we don't see that in green screen. So let's create that for ourselves. Let's move to the world origin stage floor and create more cylinders. Let's do a cylinder. I'm going to bring this out. I'm going to scale it so it's a little thinner. And let's bring it something like here. That's just fine. Let's duplicate. Bring it down, just fine. And I'm going to scale this just to make it thinner, is my thinking. Bring it up, view from the top. So these are in perfect alignment. What if they were not? I think it'd be more interesting. And let's grab another and let's lower it down. Maybe about right there. All right. Now we have elements in front of our performer. The way this will break down is we have our camera position. We have our stand-in. This will be exactly where our camera feed projected onto a plane will appear later on. And between our live production feed and our virtual camera position, we've created obstructions, foreground objects. It's a beautiful thing. And we've created depth in the background. We can fill out all of this space and we can build in 360 degrees around our stage floor. When we create in 360 degrees, that means we can place our virtual camera anywhere we like. We can move and we will always see something visually interesting. This is really close to done. Let's dive into, let's take a look at our agenda. We used prefabs. I didn't explain prefabs though. Let me explain prefabs and how to make them. Prefab is a pre-existing game object or collection of game objects that allow you to utilize reusable assets. The way a prefab is made is you create or place an element inside of Unity. I will create, let's go with a capsule. And in this capsule, I'll add a child game object, which will be a cube. I'll place the cube beside the capsule. To create a prefab is as simple as dragging the parent game object from the hierarchy into a project folder. We now see that we have capsule, which means if I delete this from the scene and I simply drag my prefab from the project window into the hierarchy, there it is. So imagine you could use prefabs, simple geometry prefabs, to create a reusable representation of a podium, a desk, whatever you wish, and a simple plane to represent the dimensions of your working production stage floor. That's prefabs. And they're incredibly powerful and incredibly useful. We used prefabs to build reusable stand-ins of our production stage dimensions. We used a virtual camera to accurately frame what our real camera will see on shoot day. And using regions, we learned to spawn objects where they belong rather than having to shuffle them around. And we quickly grayboxed our virtual environment so fast. We didn't weigh ourselves down with production-ready assets because why bother at this stage? With our graybox elements, we can take this view, this composition, to a producer, to a director, and say, here's your idea visualized. What do you think? And they can sign off on it, or they can look at it and say, I love it, but this back element is too close to the floor elements. Can we shift that some? And shifting it in Graybox is as simple as this. A simple move. The more detailed you get, the more variables you introduce into the change and iteration workflow. So if you keep it simple and paint in the broad strokes, you can iterate quickly. You're like a lean, mean, athletic machine. Let's talk about placing camera origin markers into our virtual world so that when we move to the real production stage, our virtual world and our real production stage will align perfectly. Let's place a scene locator now. A scene locator is a game object utilized by the Lightcraft JetSet application for calibrating production cameras to virtual production environments. I have a JetSet scene locator prefab here in my virtual production toolkit. I'm going to place it onto the stage floor and I'm going to align it to the corner of my desk. Now, what is in this JetSet scene locator prefab? What is it comprised of? Where does the magic happen? JetSet recognizes scene locators by game objects with the prefix of scene locator underscore. I simply have a parent object, a scene locator, and then within the scene locator, I have a cube. Why do I have a cube? Why do I have any geometry as a child at all? This is a logistical solution to an unexpected problem. When exporting virtual environments out of Unity in the USDA format, something is lost between Unity, Blender, and JetSet if the scene locator doesn't have an anchor, like a piece of geometry, to hold on to. What happens without the geometry, like the simple cube, is that the orientation and position of the scene locator is lost. As to why, I don't know, beats me, but this solution works. Of course, I don't want to see a cube every time I place a scene locator, so I've scaled the scene locator's cube down to 0.01 in scale. It's tiny. Not only is it small, but none of the scene locators are actually visible in the final virtual production. I shrank it so that it wouldn't visually clutter my scene view and world building. Now, in order to identify which scene locator we will choose in the JetSet application on production day, we want to organize our scene locators by giving them unique names. I'm going to call this scene locator underscore desk corner. And it's desk corner because it is located at the corner of the desk. Now I'm going to spin around here and make sure that we are indeed on the floor. We are. So beautiful. We are at the corner of the desk. Now, how is a scene locator utilized? The scene locator will be included in the exported virtual environment, which will be used on production day. The JetSet application will allow me to select desk corner and any other scene locator that is in the scene. When the production designer and the stagehands place the real desk onto the real production floor, I can simply walk up with my virtual sensor, drop a scene locator origin into the corner of the real production desk, and like magic, the virtual world and the real world snap into alignment. It's a beautiful, frictionless workflow. Let's talk about the benefits of using virtual talent markers before we replace our gray box elements with real production elements. So here in my personal virtual production toolkit, I have talent markers, just a folder of talent markers in various colors. And I can just place this on the floor and rotate. And let's say I want to have a talent walk from blue to green. I can just drag a green, place it into the background somewhere, and again, rotate into the orientation where I wish them to finalize their position. The reason I have multiple colors is perhaps we have multiple talent in the same shot. So for the second individual, maybe I have a red talent marker as the starting position, orient this way, and I want them to walk over to yellow, and I want them to face green because maybe green and yellow are going to be in a conversation. There we are. Now, the beautiful thing about these virtual talent markers is that they too are visualized on the real production floor, meaning you can tilt your real production camera down on the shooting stage and then have a production assistant walk up and drop a real tape mark into the same positions that overlay with these virtual marks. This allows all of your talent to hit their marks reliably, consistently between take after take after take. Beautiful. Highly efficient. Now we've got talent marks on the floor. Let's replace our gray box elements with production elements. Well, how might we go about this? I'm going to first organize my scene, create an empty parent. I will call this talent marks. Beautiful. There's my scene locator. There is my wall. And we will call these 3 cylinders empty parent. We will call them floor decorations, and we will do the same for the foreground elements. Create an empty parent, floor decorations, FG for foreground. I'm going to do the same for background here. So floor decorations, BG. Even though they are indeed, they're parented correctly, this just facilitates a very easy way of keeping track of things. All right, beautiful. So I'm just going to drag this up here. There's really no reason. It's just getting out of my way. You do want, I'm going to place this into the regions. And the reason why I'm going to have my JetSet scene locators as children of the region is that when I export my world to the JetSet application, I'm going to export regions. As the root node, I'll go to USD, export selected with children as a USDA file. And that means everything that is a child of regions will be sent to the production monitors for use on the production floor. If the JetSet scene locator were not included in regions, we would not have access to them later in the JetSet application. So that's the impetus behind their placement. Let's say we're going to have multiple scene locators, so it would make sense to have this organized. So I will call this scene locators. Now we can have as many as we want, and it's collapsible to keep our scene clean and organized. Let's do some asset replacement. Let's start here in the background. Let's say that we want the the elements back here to be houseplants. Let's go with houseplants. If I explore my assets and find set dressings, I've got houseplants. Let's drag a houseplant into the scene and we'll place it roughly here. Of course, the scale is way off, way off. So we will just scale down and fix. I'm going to place it near the center so that the placement is the same. And I will scale down until it's appropriately sized. Very close. Now I can select my cube and delete. We now have a houseplant where we once had a stand-in cube. I can duplicate and drag it into position here. And I can scale this one down. Scale it down, scale it down, scale it down. Grab the primitive, delete. Let's move to the foreground because that way we can see more of what we're doing from the camera's perspective. Okay, let's scale this down. Bring it way down to match our geometry. Beautiful. And replace, gone. Let's duplicate and relocate. Scale's pretty close, but we will come down just a little bit. I don't mind if the leaves go beyond the bounds of the cylinder. That's fine. It's not that pressing. Let's do the same for our giant houseplant. Now, these can be anything. They can be columns. They can be architectural elements. They can be anything. For our intent and purposes, they are houseplants. All right, houseplants in position. Get rid of the cylinder. Let's do the same for the background element here. Drag a houseplant into the background. Pretty close. Let's zoom in, get a good look. And we can finesse the position because we want it to be exactly where we had planned for it to be. Scale it. Pretty good. Get rid of the primitive. Primitive is gone. Now we have houseplants. Now imagine we do this for the entire world. And that allows us to say, okay, yeah, this looks pretty good, but maybe our background houseplants are being lost. It looked good in primitive form, but maybe we need to change position just a little bit. No worries. Bring this over here, and we can bring this in as well. There we are. So now we've got elements in front of our production plate. We also have background elements, and we've replaced our geometry, our primitive gray boxing. I can rotate this plant. Let's say I don't like the position of the leaves. They were a little too intrusive, a little too something. Beautiful. Now we can replace our floor with whatever type of floor we wish. We can replace our wall with any type of wall we want. We can set decorate the boxes on our wall, replacing them with anything we like. What do you think of this workflow? Isn't it fast, efficient, and pleasant? Just as every workflow should be. This is a wonderful way of beginning every virtual production project in a manner that prioritizes creativity in storytelling. This brings us to the moment where you get to ask questions. So leave them for me in the comments. I do answer them. And if you would like to collaborate on a virtual production, regardless of where you are in the world, I invite you to contact me via my website at mindcreatesmeaning.com, where you can learn more about me and my work. I will see you in the next video.